Welcome to The Explainer. Have you ever wondered how a machine actually, thinks? Today, we're going to crack open that black box and see how an algorithm learns to make sense of a totally chaotic world just by figuring out the single most important question to ask first.
To really get this, you've got to put on a certain hat. You have to think like a detective. You're surrounded by clues, a total jumble of information, and your job is to find the hidden pattern. So let's set up our mystery. We're faced with a big table of data. It's messy, it's confusing. How in the world can a machine look at all that chaos and actually learn to predict something useful? I mean, it seems almost impossible, right? Okay, check this out. This is our crime scene. The mystery? We want to predict if a tennis match is going to happen based on the weather. We've got our clues: outlook, humidity, wind, and we know whether the game was a yes or no. Right now, it's just a big, messy pile of facts. The machine's go-to tool for this kind of detective work is something called a decision tree. You can just picture it like a flowchart. It works its way through all this messy data by asking a bunch of simple, one-at-a-time questions until it gets to a clear answer. But here's the catch, and it's a big one. The whole thing only works if it asks the best question right at the very beginning. One of these questions is way more powerful than the others. So how does it know which one to pick? The answer starts with this really cool concept called entropy. In the world of data science, entropy is all about one thing: measuring the mess. Yeah, literally. It's a way to put a number on how random or how messy our clues really are. To put it simply, entropy gives us a score for chaos. A high score means your data is super mixed up and unpredictable. A low score means things are pretty orderly, and you can kind of see what's going on. It's our chaos meter. So for instance, a dataset that's a perfect 50-50 split of yes and no answers, that has the highest possible entropy. It's pure chaos. But what if a set is like 90% yes and only 10% no? Well, that has really low entropy. It's much cleaner, much easier to predict. So if entropy measures the mess, how does the machine actually clean it up? Well, that brings us to its secret weapon, a concept called information gain. And this takes us right back to our central mystery. Now that we can measure the mess with entropy, how does our decision tree figure out which single question will cut through the noise and bring the most clarity? It does it by calculating something called, you guessed it, information gain. For every single question it could possibly ask, it calculates how much that question would reduce the overall messiness. The question that causes the biggest drop in entropy, the one with the highest information gain, that's our winner. It's the best question, period. All right, theory's great, but let's see this in action. Let's put on our detective hats and solve this weather puzzle. So here we are, back at square one with our messy data. We have a mix of yes and no outcomes, so it's got a certain amount of entropy. Our entire mission is to bring that number down. Now, here's the brilliant part. The algorithm doesn't guess. It's a pure number cruncher. It's going to test every possible first question. It asks, okay, what happens if I split the data by outlook? Then it calculates the information gain. What if I split by humidity? Calculates the gain. How about wind? It tries them all. It's a brute force approach that guarantees it finds the absolute best question to ask. And right here, this is the aha moment. Look what happens when the algorithm splits the data based on outlook. Something amazing happens. That overcast group, it becomes perfectly pure. 4 yes outcomes, 0 no outcomes. The entropy in that little subgroup just dropped to 0. It's a perfect predictor. So the algorithm calculates the total information gain for each possible split, and when you look at the results, the answer just jumps out at you. It's crystal clear. Splitting by outlook gives us the biggest reduction in entropy. It creates more clarity, more certainty than any other question we could have started with. We have our winner. And just like that, the algorithm has its answer. The single most powerful, most impactful first question it can possibly ask is, what's the outlook? This question now becomes the starting point, the root node of our entire decision tree. Okay, so we've solved a simple little weather puzzle. It's cool, but why does this actually matter? Why is finding the best question first so important in the real world? Well, it turns out this simple idea of always seeking the biggest reduction in uncertainty is the engine behind technology we use every single day. It's how your email filters spam out of your inbox, how banks decide if you're a good credit risk, and even how doctors get help diagnosing diseases. And that kind of leaves us with a final thought, doesn't it? When you boil it all down, this super powerful algorithm is really just a systematic search for clarity. It's a hunt for the question that cuts right through the noise. And you have to wonder, what could we learn if we tried to do the same?